Hi, guys. Today we're on Unit 11, Lesson 5, and we're going to be writing the equation of a tangent line. Okay. Before we begin, we just want to go back to yesterday's lesson. Remember that yesterday we introduced something called the power rule, or the shortcut method for finding a derivative. So if f of x equals x to the n, or if f of x equals c times x to the n, just if there's a number out in front, then the derivative is n times x to the n minus 1, or n times c times x to the n minus 1. Remember, though, all we do is bring the power down in front, multiply it by whatever number's there, subtract 1 to get the new power. If our term is just an x with no power, then it's just the number, the coefficient out in front. And if the term is just a constant, then it just goes away. It's just 0. We also want to remember that the derivative, right, our f prime, is a rule or a function to find the slope of the tangent line, or the instantaneous rate of change of f of x at a specific x value. So let's begin just by kind of putting that into practice right now. If f of x equals x cubed plus 3x minus 1, we want to find the instantaneous rate of change at, of course, I have a typo. This should be at x equals 1. So let's just fix that in our notes real quick. So the instantaneous rate of change is the same thing as saying slope of the tangent, or f prime. So in order to plug into our tangent rule, right, our derivative, we have to first go back over to our function, find the derivative of that function, which would be 3x squared plus 3. And then we're going to take that derivative, and to find the slope of the tangent line at that instant, we're going to plug 1 into our derivative. So basically, the slope of the tangent line at that specific x value is going to be 6. So there are many useful applications of the derivative in calculus. The first application we learn is how to write the equation of a tangent line. So let's go back to our function for a second. Let's look at the graph of this function so we get an idea of what we're doing. I put it into my calculator. We're going to just look at the picture. This is our function. So if you think about it, our picture looks something like this. This is not going to be a perfect picture, but our picture looks something like that. We're writing the equation of the tangent line when x is 1. So our point's going to be somewhere here. We're going to figure that out in a minute. Basically, what we just did was we found the slope of that line. That's what we did. The slope of this tangent line is equal to 6. But we want to write the equation of the tangent line. Now let's think back to earlier in the year. Okay. What do we need to write an equation of a line? We need the point, we need the slope, and we need to plug it into our point slope formula. This is why I was so adamant about you guys getting used to using this method. Some of you still kind of are trying to avoid it, but right now we're going to have to use this. So write the equation of the tangent line at x equals 2. Again, we're going to carry down our x equals 1. Okay, we're just going to kind of reuse this information. Okay. So we need the point. How do I get the point on a curve? If I want to point on this actual curve, I'm going to plug into the original function. So when I plug in 1, I get 1 plus 3 is 4. 4 minus 1 is 3. My point is 1, 3. The slope, well, we found that in the example above, right? We took our derivative function and we plugged in 1 and we got 6. Now, all we're going to do is put this together. Y minus y1 equals my slope times x minus x1. A lot of times in our calculus course, we can leave our equation just like that. There are going to be some times when the question or when it's a multiple choice, they want you to recognize it kind of like that, which we call the linear approximation form, which is not a big deal right now. Or you could be asked to kind of distribute and simplify, in which case that would be our equation. Okay, but just remember, if we can get this far, we're good. And our goal is to eventually kind of be able to recognize all the different forms. Okay. So let's just kind of write down some steps for finding the equation of a tangent line. If we're looking to find the equation of a tangent line on a given function, so this is my function, this is my tangent line. We're going to find the point, plug xy, plug x into f of x to get y. We're going to find the slope. We're going to plug x into f prime of x to get the m. And then we're going to put it into our formula. That's really it. Okay. Write the equation of the tangent line at the given value. So my function is f of x equals x squared minus 4x. At the point 3, -3, well, this is nice because my point is given to me. Let me just make sure that that's right. Yeah. So what do I have to do? I'm given the point. I want to find the slope. Well, to get my slope, I need to find the derivative for this function. F prime of x equals 2x minus 4. F prime of 3 equals 2 times 3 minus 4. So my slope is 2. And all I'm going to do is kind of put that information together. Y minus y1 equals m x minus x1 into my point slope form. Y minus -3, y plus 3 equals, my slope is 2, x minus 3. Remind you that you can write it like this. Or we can distribute and clean it up. I hope I didn't make any mistakes there. Let me just, yeah. So here's my original, which is perfectly acceptable. Here's my linear approximation, which you just have to know about. And here's in what we call like our, official y equals mx plus b form. Again, this is okay. Some of you just may feel the need to do that, and that's fine. We're going to go back up to our original function. And now we want to find f of x. We want to find the equation of the tangent line at x equals 2. This time I'm not given the point. So I have to do the work to get the point. F of 2 equals 2 squared minus 4 times 2. 4 minus 8 is -4. So my point is 2, -4. We're going to do the work to get the slope. Remember, we're going to use our derivative, which we got already, and we're going to evaluate that when x is 2. So here my slope is 0. No big deal. Y minus y1 equals m x minus x1, y plus 4 equals 0 times x minus 2. Oh, but here you might want to clean up, because what is 0 times anything? It's 0. And this is just the line y equals -4. Let's look at our picture. Let's plug in our original function for a moment. If we look at this picture, and I look at that graph here, what does this mean to me? There's my parabola. Okay, I'm just going to kind of quickly move it over here. So I have my original parabola. The first equation we wrote was at the ordered pair 3, -3. So our first tangent line was this guy here, right? And the second tangent line we wrote was actually here. And that's our horizontal, right? That's our y equals -4. If you remember from the other day, that's where our slope is 0. Okay. And that's actually a minimum value on the curve. And we will be kind of, dealing with problems like that in the future. Okay. Today, it's just about getting the equation. Now let's look at something a little different. Another type of line you may be asked to deal with is the equation of a normal line. Okay. Now the definition of a normal line is just a line that is perpendicular to the tangent line. It doesn't come up that often. I'm just introducing this concept. But if we're dealing with just a general kind of situation here, and this is your tangent line, the normal line, if you're asked to write it, is that guy there. So it's perpendicular. What do we know about perpendicular lines? They form right angles. So we're going to follow the same step, but the slope of the normal line, when you put it into your formula, you're just going to take the negative reciprocal of the slope of the tangent. Okay. So if we're writing this at the point 3, -3, well, we already have the point. We have the slope of the tangent from above. So the slope of the tangent line at this point was 2. So the slope of the normal line will be -1/2. And if you go back over to your curve here, the normal line would be that guy there. So it actually kind of matches if you think about it. What we just did, now we're just going to plug this information together. Y plus 3 equals -1/2 x minus 3. And I'm not going to bother with rewriting that one. I'm just going to kind of leave that alone there because it's just going to be dealing with fractions. And at this point, I just want to get on to the next example. In example 2, we want to write the equation of the tangent line. Now here's where this gets useful, because now think about it. If we had to do f of x equals 1/x with the definition of the derivative, it would be long and complicated. But now if we want to get all this information, right? If we want the point and the slope, now things are a lot easier to work with. Y minus y1 equals m times x minus x1. Whenever I write the equation of a tangent line, I just set up all my information on the top of the page like that. So if I want to get the point, that means I'm going to plug 2 into my original function. My point is the ordered pair 2, 1/2. If I want to get the slope, I have to find f prime of x. In this case, I'm going to have to rewrite f of x first, then find the derivative. Then plug in 2. I'm going to take my point, my slope, and substitute it into my point slope formula. Y minus 1/2 equals -1/4 x minus 2. Maybe I should let you do some fraction work so we could rewrite this. Y minus y equals 1/2 minus 1/4 x plus 1/2. 1/2 plus 1/2 is just 1. -1/4 x plus 1. Again, that's acceptable for me, but you should also be able to recognize this if I ever gave you something of a multiple choice or asked you to do more. Write the equation of the tangent line to f of x equals x to the 4th minus 2x squared at the point 2, 8. Point slope. I'm just going to kind of work through these because now we should have it down pat. You can pause the video if you'd like and try it and then just look for the answer. Okay, because it's just 2 more examples we're going to do. So I'm just going to kind of do the work for them. And you could just follow along and check your answers. So my point is 2, 8. I'm just going to leave them alone. I'm not going to rewrite. Write the equation of both the tangent and the normal line. And again, I'm leaving both of them in the point slope form just because the other math is stuff that you should be able to do on your own. Okay. Thank you guys. Have a great day.